right, today we're going to talk about concentrations. We're going to quickly go over the qualitative descriptions. Hopefully after the POGL you have a good idea of these. The two descriptors qualitatively, looking at the pictures here, you see there's a solution over on the left that is described as being dilute, and that's a solution that contains a relatively small amount of solute. That means you're going to learn the term molarity today, but that's the word dilute. So if you have a little bit of solute and a lot of solvent, then that's a dilute or dilute solution. And then in the middle, you have a concentrated solution. That means you have a large amount of solute. So a concentrated solution. And so you can see just from the picture that it's a little darker. So if you have some coffee and you see that it's darker, then you know that it's stronger coffee. That would be more concentrated coffee. On the far right-hand side, you see it's a term saturated. So you also learn the term saturated. Saturated means that it has the most of solute that it could possibly take at that temperature. And so the color is even darker. All right, so it always refers to how much solute is dissolved. Next, we're going to talk about a quantitative description, because in chemistry, we're all about numbers. If you haven't figured that out, some kids complain and say this is another math class. But it's because we don't like it to be open to interpretation. What one person might call strong coffee, another person might call weak coffee. And so if somebody's talking about a solution and saying it's concentrated, that's just not enough for us in chemistry. Think about medicine. If a doctor prescribed a medicine and just said, oh, give that person some strong medicine, that wouldn't be good enough. We need to know exactly how much of the medicine would be necessary to treat a certain disease or disorder in order to get somebody to be well. So, concentration is a term that you've heard before, and it is a measure of the amount of solute that is dissolved in a quantity of solvent. So you can't just say it's how much solute it is, because it's got to be also in how much solvent it's dissolved in. So think about that. That's actually, it's a ratio of solute to solvent, kind of. And it's not always just solute to solvent, as you'll see in the next specific unit for concentration. But in general, it's kind of a ratio of solute to solvent. There are lots of different units for concentration. For example, environmentally, you might hear people talk about units like ppm, which is like parts per million. If they're going to like close the beach or things like that, they might be talking about certain things that are in the water in ppm, parts per million or parts per billion, maybe ppb, different things in the air, stuff like that. But in chemistry, the main unit that we like to use is molarity. And sometimes in our labs, you might see labels on beakers with a capital M. And that's what we've been using, which is molarity, which stands for the ratio of moles of solute per liter of solution. Again, there are others, but this is the most common unit in chemistry. So again, that stands for moles of solute which might come from grams over liter of solution. And you might, I just want to point this out, this might come from, oh, I didn't spell from right, come from milliliters. So I just want to point that out. We're going to talk about that a little bit here in a minute when we have some reminders. All right. So in the box here, we're going to put our equation. So molarity, again, it's a capital M. And that is moles of solute. Sorry, my dogs are barking. Per liter of solution. So not just the solvent, it's got to be the entire solution. So some quick reminders just to make the math go a little bit faster. When you are converting grams to moles, just a reminder that you will divide by molar mass. When you're converting moles back to grams, in case you have to do that, you will multiply by molar mass. When you are converting milliliters to liters, you will divide by 1,000. And when you are converting liters back to milliliters, you will multiply times 1,000. So this is when you're doing like dimensional analysis. All right, another thing, I know some of you struggle with the algebra when we're doing these conversions. So when we did our density problems, we did a triangle to help you out. So we're going to go ahead and do another triangle to help you out with this set of conversions. So in our triangle, we're going to put our M and our moles and our liters. In addition, because as I stated earlier, you're not always given moles, I'm going to, outside of that triangle, put your grams and put your milliliters, and remind you that you might have to transfer in and out between grams and moles and between milliliters and liters. The last little reminder here, or I guess introduction of a piece of equipment I want to put here, is this little handy dandy lab item, which is called a volumetric flask, because we didn't get to use one in the lab. And it looks kind of like an Erlenmeyer flask. It doesn't have the sharp triangle on the bottom like an Erlenmeyer does. It's a little rounded. And then at the top, it's got a little kind of cork, but it's not a cork, but it's got a stopper at the top. So if you were preparing a solution of a specific molarity, you would take this lid off, and then it's not like a graduated cylinder at the top, but it's got one specific line in it. You would only see one little teeny etched line, not like a graduated cylinder that has a bunch of little lines on it. You'd only have one little etched line. So this one is a 250 milliliter volumetric flask. And so it's just got one line, and so that line is where 250 milliliters is. So if you had to make a solution of a specific molarity and you wanted to make 250 milliliters of it, you would know to add the certain number of grams, whatever you'd calculate, that's how many grams you would need. You would add that to a little bit of distilled water in that flask, and then you would add the distilled water to exactly that little line, and then you would put that little cap on. You would invert the volumetric flask, and then you would know that that molarity would be exactly whatever you had calculated it would be. So it is kind of what we call calibrated to be a specific molarity. So these are instruments in the lab that are specific. So these are what we call volumetric flasks, and they are made to be used to create solutions of a specific molarity. And that's all we use them for in the lab. So if you've seen them around by my sink, they are what I use to make your solutions for the lab. All right, in the next video, we will do some sample problems for this. So make sure you have this page of your notes handy, and the triangle and your calculator, as well as these reminders for converting grams to moles, moles to grams, milliliters to liters, and liters to milliliters.